Welcome. We're going to do question 78, 79, and 80. So let's do it. 78 states Lauren is enrolled in a large college calculus class. On the first exam, she got a mean 75, standard deviation 10. So we're writing that out. X bar 75, S of X 10. There we go. That's what she got. Or excuse me, that was what the class mean and the standard deviation was on the first exam. The second exam, it states the class mean was 70, the standard deviation was 15. So second, S sub X is 15, X bar was 70. So, relative to the other kids in the class, Lauren scored better on the first one. She got, oh, interesting, she got 85 on both exams. So it looks as if that might be a little bit better on this exam, 85. 85. She got an 85 on both exams. On average, the kids in this first exam got a 75. On average, the kids in the second exam got a 70. That's what we need Z for. So this is actually a total algebra 2 question. I'm going to write AP statistics. Z is equal to A minus P over S. And I'm going to compare these two values. So the actual score she got was 85 on both tests. So I'm going to fill that in. And the predicted, so we would predict on average on the first test, she would have gotten a 75. And on the second test, she would have gotten a 70 because that's the average. And so I've set that up there. And so the top one is my first test. What's the Z score I got on the first test? What's my Z score on the second test? And I have to put that over the standard deviation. So the standard deviation on the first test was 10 and the second was 15. So I have two formulas to compare. So when I take A minus P, I get 10 over 10. That's 1. So her Z score on the first test was 1. So she scored 1 standard deviation above the mean on the first test. 85 minus 70 for the second test. She scored 15 points above the mean on the second. And the standard deviation of a typical student was also 15. And so look at there. It appears as if she scored equally well on both exams because both exams she scored 1 standard deviation of the mean. And this is how we compare tests like this, like compare the ACT with the SAT score. We standardize it and we use Z-score so we can put them on the same playing field of comparison. Great question. Next one. 79 states suppose that 30% of subscribers to a cable TV service watch Shopping Channel at least once a week. You're trying to create a simulation. And so which one, if we were assigning digits 0 through 9, would be appropriate? So we're trying to set up a simulation that would simulate a 30% of the time type of a thing. So usually if it's only a few numbers, I go ahead and write that out because, again, I want to make sure I know how many numbers I'm dealing with. So when I write out the numbers 0 through 9, I recognize that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, and that's my 10th number. So out of the 10 numbers, I'm going to designate 3 of these to signify at least once a week these people are watching. So it could literally, nobody would be random, but it could literally be any 3 numbers. Any 3 numbers if we designate these 3. If we designate these as you're watching television, we could do a random generator. And if you get these 3 numbers, you would have the opportunity, the probability of getting these 3 numbers out of all these numbers, you'd get those 3 out of 10 or 30% of the time. So when I'm reading through this question, it looks like A is going to be my answer because assigning 0, 1, and 2 are 3 numbers out of 10. If I look here, this simulation would be great if I was trying to simulate 40% of the time, because that's 4 numbers. That would be 50% of the time. This would be only, D would be only 1/6 of the time, so that would be kind of weird, but that would be 1/6 1 divided by 6, or 16.6 repeating percent of the time. And the last one would be if we only designated the number 3, that's only 1 out of 10 numbers, so that would happen 10% of the time. So once again, pretty obvious, the answer to the question is A. Let's take a look at the last one, question 80. So question 80 states, I'm looking at the table, I'm looking for the word expected, and I see it right there. So my expected value, my formula is x parenthesis x. I want to take my x value times the probability of getting that x value, and they made a nice little table here of here's all my x values, and here are the probability of getting it. And then, remember, I'm going to squeeze in a little sigma sign, which is a fancy way of saying sum it all up. So I need this times this, plus this times this, and that's what that symbol means. So this times this, plus 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 this times this, and add it all up. So let's write that out. 0 times 0.3, 1 times 0.2, 2 times 0.3, plus 3 times 0.1, plus 4 times 0.08, plus 5 times 0.02, yada, yada, yada. Add it all up. I get D, but not really. So let's take a look. I end up getting, I don't get D. When I add these all up, I expected to get for X 1.52. So I'm going to have to keep reading the problem to figure out what happened. It says, I expect to sell, after my calculation, exactly 1.52 sweatshirts. So I'm expecting to sell on average between 1 and 2 sweatshirts. So if each sweatshirt sells for $25, that's where this different number came in. So if I multiply by $25, I get $38, and that's why I got D. Thank you for joining us.